Hello and welcome to a presentation on database management systems. So, before we get started, let's clear some terms. When we talk about database or database management systems, the word data, database, and information comes to mind. So, what is data? Data is any fact that has been recorded, and this fact must have some sort of implicit meaning. And so, for instance, let's say that we collect in data um, about all the students in a classroom. So that data could include all sorts of things: a student's height, the student's grades, the student's date of birth, the student's name, the student's age. So all of this is data. Now, what is information? Information is when the data has been processed or when some sort of cleaning or some sort of work has been done on that data. So, that is information. Um, and basically, information is also something that is relevant to us. So, in this example, wherein we have the data about all the students in a classroom, the if we want to discuss about the marks of a student, so that would be our information from the data that we have. So information is a subset of data. And what is database? So if I were to accumulate all the data that I have of such students of multiple classes in some sort of a file structure or a data structure, that would be a database because it is a collection of related data. And what is a database management system? It is a software that can be used to create such a database. We can define the database, we can construct it and manipulate it using database management systems. So moving on, before we discuss about database management systems, we need to understand what was used before such systems came into place. So earlier, file based systems were used to manipulate and store data. So take an example. Let's continue with this example of students in a classroom or in a school. So if I were to store information about each of this student, so I could have information about their fees. Have they paid the fees? What fees have they paid? Their marks, their age, what extracurricular activities are they into? So all of this, it could be in a separate file of its own, and that is usually how information was stored on computers on before database management systems came into place. All of this information, the extracurricular activities that students were are into, fees, their marks, all of those stored in permanent files. Now, the way to write files to a system would be to use some sort of programs to create each file on a system. So, of course, all of this had severe disadvantages. So the one of those is you would need to create a new sort of program for each file that had to be added. Then second, data redundancy. So what this usually means is data redundancy. A file, let's say there are multiple files. Two files could have the same data in both the files, and we wouldn't necessarily need that data in both places. That data could be in one place referred to by both the files, but because we are using a file-based system, data is unnecessarily stored in both places. Third disadvantage is data inconsistency. So if I were to have some data named marks in one file and the same marks data in another file, file A and file B. So if the marks was updated in file A, but it was not updated in file B, then this is a case of inconsistent data. So in this whole file system that we have, two files have in conflicting data of the same field. So marks has some different data in file A and some different data in file B. So there's an inconsistency. This inconsistency is not handled by file based systems. Moving on, data isolation. In file based systems, data isn't isolated. So there is no clear segregation. Then security concerns, even this is a major disadvantage, as You'd have to deal with privilege to access, read and write access. Then a major drawback is no concurrency. Database, what does concurrency mean? So if I have many users trying to access this file based system, so in such a case, if one user were to access this system and another user is accessing the same file in that system that this other user is trying to access, user A, let's say user A is accessing the system and user B as well. So if user A were to access it first, at that time user B will not be able to access it. User B will have to wait for its turn. So that is how what actually means by no concurrency here. That's handled by database management systems. At any given point in time, more than one user or client can access the database. So let's move on to what actually database management systems are. So all these difficulties that we discussed right now, that actually led to the creation of the database approach. Sophisticated softwares were created to define, construct, and manipulate such databases, and they came to be known as database management systems. So, what do these systems allow users to do? They allow them to define the data that will be stored in a database. They allow the user to update the data quite easily or to retrieve any sort of data easily. So you could use some sort of language like SQL to query the database to update it or to retrieve data from it. Now, database management systems also provided an administrative usage of the database. So there could be an administrator who would grant access to various people and to what level a person can see into the database. Such a sort of thing could not be achieved with file based systems. And of course, database management systems are concurrent. So at any given point in time, more than one user can access it and it's easy to use. So let's discuss some benefits of database management systems. First one being ease of accessing data. So it's quite easy to access data using database management systems because such systems usually come equipped with some sort of a GUI that allows us to manage the data, to view it, to access it. Second, it deals with data redundancy. Um, Actually, there can be data redundancy here, but usually database management systems, let's talk about relational database management systems, you could define a table and let's say that table holds marks, right? And then there could be two other tables that reference that same table, so there would no longer be redundant data. So the two tables that are referring marks, they need not hold marks again, so there won't be any data redundancy. Marks won't unnecessarily be stored across both those tables, and that is how data sharing also comes into picture. And data inconsistency is also resolved using database management system in such a manner, because if I were to change marks in one place, that is that table, it would reflect in the other two tables as well that are referencing marks. Moving on, concurrency, as discussed, database management systems are concurrent. They allow more than one user to access it at any given point in time. Fifth, self-describing nature. So database management systems, they are said to be self-describing. So what does this mean? um, Database management systems did not only hold the information about the database, they also, or the data that is in a database, but they also hold some sort of metadata. Now what this metadata does is it describes what kind of data is in the database. So are we holding strings, are we holding date and times, what is the relation between each table in the database, so on and so forth. Moving on, security concerns, like previously discussed here. So there is an administrator of a database who is going to provide access levels, privileges, and so a person with, let's say, a privilege 0 can't access stuff on privilege 1 level, privilege 2 level, right? So that's how we deal with security. And database management systems these days are quite sophisticated, so they have backup and recovery subsystems. So what this means is, if you're writing something to a database and in between there is a crash or an error, and the data is not completely written. So there are recovery systems in place that can roll back the transaction that had occurred. Transaction here means the action that occurred between the user and the database. They can roll it back and return the database and whatever the user had been writing to its previous state before the crash had occurred. So they have these recovery subsystems. They also have backup systems. So if your primary database is lost, you usually have a backup somewhere. Maybe it's written somewhere on the cloud or some other place, right? So you have backup systems. Moving on, let's discuss asset properties of database management systems. So this is quite an important property in DBMS. And what does asset mean? The A in asset stands for atomicity. What this means is, if a transaction were to occur in a database, so atomicity dictates that either the transaction will happen at once or it won't happen. It's usually called all or nothing. So what this means is, let's say if I my database were to handle me transferring money to some person B. So a person A is transferring money to person B, and in between something so person A transfers money to person B and person B transfers money to person C. So this won't fly if just a transaction that is transferring money from person A to person B. The whole transaction has to occur. That is, money goes from A to B and B to C. That's atomicity. So either all of the transaction happens at once, that is prescribed, or none of it happens. So, and then moving on, C in asset properties stands for consistency. So what this means is, if I when we define a transaction in a database, that transaction must adhere to some of the constraints that we have defined previously. So where a transaction, it can only occur if it's transferring a database from one consistent state to another consistent state. If the database is moving from a consistent state to an inconsistent state, the transaction will not occur. So that's consistency. Moving on, isolation. Isolation is all about concurrency in database management systems. So what this means is, multiple users, multiple transactions can occur independently without interference. So each transaction has a copy of the data that they can use to carry out the transaction. They need not wait for other the other transactions to complete. So there are various ways to implement isolation. One of the ways is serialization. It's the most robust way to implement isolation, but it is also quite expensive, because in serialization, each transaction has to wait until the next transaction is completed. Durability, the D in asset property stands for durability. It just defines how durable a database is. So what this means is, database management systems, they have backup systems. So even if the changes of a successful transaction occur, even if the system fails. So if the system were to fail, the changes would be logged into some sort of file. So how durability is achieved? Using write ahead log files, or all of this is written someplace else. So if the database were to fail, we have a backup, or we have a log file where it's written into. Moving on, I discussed a lot about data administrators uh, how data administrators manage various privilege levels. That's where database management system abstraction comes in. So database systems are usually made using complex data structures and processes. These complex structures uh, these complex